Hello everyone. In this video we are going to discuss about different stages of compilation in embedded C programming. Please watch the previous videos if you have not seen and do subscribe the channel for further videos. Okay, let's come back to the terminal and we will search for the GCC version now. Yeah, here I have installed already the GCC cross compiler. If you have not installed, please install by referring this video ARM based GCC cross compiler installation so that you can see it in the terminal. So we are going to discuss here about what are the different stages of compilation stages. So here you can see the stages: preprocessor stage, compiler stage, assembler stage, and the linker stage. In stage 1, it is a preprocessor stage. What it will do, the action is it will expand the macros and it will include the header files and it will remove all the commands and it will perform the conditional compilation. Now first type the compiler name ARM-NONE-EABA-GCC compiler. So the command is -e and the source file name main.c here and -o. It will create a file main.i. It will create extension with the .i. You can see main.i file is created, which is included all the header files first. You can see in main.c here you can see the standard init.h file. It is included in main.i. Now we will see how the macros will get expanded during pre-processing stage. So I will create a variable init temp and I will assign some macro into it. So I will create a macro as hi semicolon. Now I will define a macro hash define hi. I will assigning to 1. So high will be replaced with 1 during pre-processing stage and I will assign this temp into while loop. Now I will recompile this. Now we will go back to .i file and I will search for temp. You can see here the high is replaced with 1 in the pre-processing stage. Okay, now we will see what is conditional compilation. So I will put hash if 0 and I will close this hash if window using hash end if. Now this has to be commented during pre-processing stage. So I have compiled it again and I will go here. Now you can see there is no variable creation here. During pre-processing stage, it will eliminate it and it will eliminate the comments as well. I will create a temporary comment here. Temporary comment. Yeah, this will also get eliminated during pre-processing stage. I will recompile it. Now I will go back here. You can see here there is no comment here. So this is how pre-processing stage will work. Now we will see how, in case if we need to include files during compilation, how we need to be done. So I will create a header file in drivers folder. I will create it as a temp.h. So I have created a header file. Now I need to include that header file during compilation. So what I will do, first I will include this header. First I will uncomment this so that no error will be there. Okay, first I will compile it down. Now I need to include that header file. So I have to use a flag called -i and I have to tell the folder name from which folder I have to include. So there is a temp.h in drivers, so I have included that. Now I have compiled this. Now I will go back here. Now we will include temp.h in the main.c folder so that we can use this temp.h during compilation. So I will include this file. Now I will compile by including temp.h file. So I'll use the same command. Now the header is included during compilation. Now I will come back to .i file. Now I will search for a temp. You can see here inside drivers folder, the header file is included using this -i drivers. Okay, now we'll come back to main.c. Now we will define macro values during a pre-processing stage. First, I will undefine this macro value and I will compile. Let's see .i file and I will search for a temp. You can see here I didn't define any values here. So we will go to main.c file and I will add a -d flag and I will define I equal to 1. Now we will enter. It will replace I with 1 during pre-processing stage. Now I will enter it. Okay, it shows I redefined. So we no need to redefine here. So I will comment this as define high so that I can define high value during compilation process. So in my .c file there is no high now. So I will use the command. Now we'll go back to .i file and see what is the value of a temp. You see here, based on the high value it is defined during compilation, it is applied in the .i file. So this is what a pre-processing stage means. Now we will see the second stage of the compilation, which is compiler stage. So here it will convert a C code into a assembly code. It will use a .i file as an input and it will generate .s as the output file. Okay, we will see it in the terminal now, how we can use these commands. Okay, let's change the command now from pre-processing stage to compilation stage. Now I will change the input file as main.i and I will change the command from -e to -s. Then I will change the output file extension as -s. Now I have compiled this. It will use the .i file and it will generate the assembly code. This is called the compilation stage. So here there are different flags are there. We will see one by one what is the purpose of each flag. So first I will go with hyphen wall. It will generate the warnings, whatever the warnings are there, it will show it in the terminal. So you can fix these warnings. Now I will use another command hyphen w error. It will throw a error. Whatever the warnings are there, it will consider as a error if you are using hyphen w error. So we can use this function in projects. So in case if you don't want any warnings in your project. So you can clear these warnings by I will change void to int and I will return 0 so that I can remove this warning. So now I will compile it again. Okay, still I'm facing error. Okay, what I can do now is since I was using a old pre-processing stage file, so I will recompile it again by using a main.c file. Now it is compiled without throwing any error. Now I will clear this terminal. Now we will see other flags. I will change to, I will add a hyphen O0. It will do different types of optimization. First, I will use hyphen 0 and we will enter. Then we will go back to .s file and we can see the total number of lines here. You can see around 146 lines of assembly code. Now I will change this optimization to 001. Now I will recompile it. Now you can see it reduced to 82. Now I will change to O2 and you can further reduce the number of lines of code. It reduced to 73 and I will show to O3. It is same as O2. Now we will go back to hyphen OS, which is a compact size for the controllers. Now it reduced to 67 lines. So this is how this compilation compiler optimization flag can be used. 0 to 3 and OS. The S should be a small. Then we will see one more flag hyphen G. It will be used whenever you are doing a compare, whenever you are using debugging. So you can see here number of lines got increased. So this flag will be used only for debugging purpose. Okay, I will remove this as of now. We will see uh, how the next stage of compilation works. Now the third stage is assembler stage. It will convert the assembly code into the machine code, which is a object file. So here the input file will be either you can use .s file or a .c file, and we will use the command instead of -s we will use a -c. Let's go back to the terminal and see how this command works. First I will use instead of -s I will change to -c, and I am using a main.c file only. I'm getting some error now. We should not use a caps, so we have to use a small letter. So now it got compiled and it generated a object file. Now the object file is generated based on the computer libraries. So in case since we are using a controllers, we have to use a controller specific compilation. So I will include a flags called -mcpu hyphen sorry equal to cortex hyphen m4 and one more flag -m thumb. So now the object file will get created based on the controller specific. I'm using STM32, right? So this additional flags can be used during a compilation. Now we have compiled only the main.c. Now we have to compile a startup file as well. There is one more file. So I will change the file name to startup. Inside startup folder there is a file and with the .s extension, and I will create with the same name object file. So it will create a object file of startup file. Now you can see under platform folder you can see main.o and startup.o. There are two object files created now. Now the next stage is the linker stage. It will link all the object files and libraries and resolve all the references, and it will create executables. Those executables can be flashed directly into the controllers. We will see how it will work in the terminal. Let's go back to the terminal now. Now we will write the complete command from the beginning, and we will link all the object files. First I will use the compiler name -n-eabi-gcc. This is for compiler, and I will use the main.c file, and I will use the startup file under startup folder. I have to add this source file as well. Then I will use -i to include the header file, and I will include the folder name here. Now I will use -d I equal to 1 so that the macro will get replaced in main.c so that no error or warning will get thrown. Now I will use one more flag -val to create warnings, and I will use another flag -w error. It will consider warning as a error, and I will use a optimization flag as OS. It will be used for embedded platforms, and I will use the controller details controller flags -cpu cortex m4, one more flag -m thumb. It will convert the thumb instructions. Then I will use double quotes sorry, it should be double quotes hyphen WL comma hyphen map equal to map file name, my first project dot map. It will create the memory map layout using the executables, and I will use -t, and I will specify the path of the linker file, linker slash linker.ld. So it will use this linker file and it will create a executable file. And during compilation, I don't want to use the standard libraries of Windows. So hyphen no stand lib, and I will create a executable file with extension of .elf for microcontrollers. So this command will generate a ELF file and a map file for my project. This map file will get created based on the memory layout which we have defined in the linker file. Now we have to create a binary file. In most of the projects, companies will use binary file. So I will use the compiler arm-none-abi obj copy. I will use this exe file, and I will use -o as the flag, and I will create a binary using binary command, and my first project .elf as the input, and I need to create a binary file with the .bin extension. Now I will run this command. Now you can see .bin file got generated here. So it is like a zeros and ones. You can see it in XView applications. And we need to create a X file in some of the projects. So we have to change binary to IX, so that and we have to change the extension with hex. So it will create a X file based on the ELF file which is generated using a GCC compiler. Now we can find all the files: binary, ELF, X, and map file. These are the four files commonly used in most of the embedded projects. So now we can use some other commands here. I will remove all of this, and I will remove hi x. Now I will use, instead of obj copy, I will use a size, so that I can get the size of each sections whatever it is used in my ELF file. So these are the commonly used commands in most of the embedded projects. Now all these commands are very difficult to run every time whenever you are changing something in the project. So instead of writing all these commands, we can create a makefile. Using a single command we can run all these things. So we will see how makefile works everything in the next video. Thanks for watching the video, and do subscribe the channel for more videos.